Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on exponential functions. Now, just to get us started to maybe explain what an exponential function is, you might see a graph of an exponential function look something like this. This would be an exponential function as opposed to maybe a linear function. A linear function would be here and something that just is a line. Try to do the best I can with a line here. And you can see that a linear function may grow faster at first, but toward the end, at some point the exponential function will surpass it and will surpass it by far. Notice the white graph function is going to be going much higher, much quicker than the green linear function would be. You see exponential functions, well, for example, maybe in some kind of a pandemic, like the Black Plague or the coronavirus or something. At first, you don't have too many cases, but then day after day after day, it starts to kind of explode exponentially. It starts to rapidly increase with the number of cases that are there. So at first they don't start, it's not linear, it's not the same amount each day. No, it grows exponentially. So exponential growth is something that some people may even say what compound interest is. Compound interest, when you put money into a bank, a savings account, or a mutual fund, or some type of investment, it doesn't really grow very much during the first few months or during the first few years. But as you leave that money in there over time, and the compound interest accrues, for several years, toward the end, that's when it starts growing exponentially. There's a big growth. I think it was Albert Einstein who actually says that compound interest is one of the greatest forces in all of nature, right? Because at the end when you're getting ready to retire, right, your money can grow largely, exponentially. So that's what we're going to be taking a look here in this video is exponential functions. So what we want to take a look at first is what an exponential function looks like the equation. So we have here y equals 2 to the x. Notice it's the exponent that's the variable. This right here, y equals x squared, it has an exponent in the equation, but the exponent is not the variable. This is just a power function. This is a quadratic, right, a parabola. So notice the difference. The exponent is going to be the variable. So y equals 2 to the x. So let's just make a table real quick and see what this graph looks like. So I went ahead and made a table here. You can see 0, 1, 2 to the 0 is 1. Anything to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is 16. And I even went backwards and then 2 to the negative 1. 2 to the negative 1 is not a negative number. 2 to the negative 1 is 1 over 2 to the first, right? So I plotted these points already, and you can kind of see the graph is going to look like this. And by the time it gets to 4, it's going to be way up there out of my screen, right? And then as it comes down here, it's never actually going to get to this 0. It's going to get closer and closer, but will never cross this x-axis. We call this x-axis an asymptote. And an asymptote is simply a line that approaches a point but will never intersect it. It gets closer and closer and closer to this x-axis, but it will never get there, never go under it. So let's look at another exponential function. This one's y equals 1/2 x. I notice I already made a table, made some points. You got 0, 1, so same point right there. 1, 1/2. 2, 1/4. 3, 1/8. And then negative 1 is up to 2, right? So you can see this exponential function is looking like something like this. Just a quick sketch of it. Again, it's going to approach this asymptote, the x-axis, never get there. It's going to get closer and closer. And as you go to the left, it's going to explode. And the farther you go to the left, the higher it's going to go up, right? So these are just exponential functions. The way that we generally graph these is make a table. Now, once you do a few of these, you can kind of get an idea of what they look like, and they'll just translate, they'll just move around. But for now, I'll probably just focus in on making a table, plotting a few points until you know what the graph looks like, and then you can, if you know where the asymptote is, that's kind of an important part. Then it approaches that line, and then it just explodes in the opposite direction. So let's do a few of these problems by making a table and then graphing, right? So let's graph y equals 4 to the x. So to make a table, you just make an xy table, and you just plug in points. I'm going to plug in 0. 4 to the 0 power, anything to the 0 power is 1. So 0, 1, plot it right there. And then you try maybe 1. 4 to the first is 4. So 1, 1, 2, 3, 4, already up there. If I tried 2, that would be 16. That's not even going to be on my screen. That's going to be way up there. So this one's going to explode really quickly. Now, it's always a good idea to go the other direction. So negative 1. So 4 to the negative 1. 4 to the negative 1 is not negative 4, right? 4 to the negative 1, we get a negative exponent. You drop it into the denominator of a fraction. So 4 to the negative 1 power is actually 1 over 4 to the first. And 1 over 4 to the first is just 1/4. So at negative 1, we're right there. If I were to go ahead and try negative 2, that would be 4 to the negative 2 power, which would be 1 over 4 squared, which is 1/16. And that's really close to the x-axis, right? So it's going to look something like this. And it's going to look like the y to the 2x. It's just going to explode a lot quicker, all right? A lot quicker. So this would be a graph of y equals 4 to the x. Now, let's look at one where you have a negative in front. So y equals negative 4 to the x. So again, let's just make a table. Let's plug in some points. So you got to do the exponent first. Order of operations, exponents before this negative in front. So it's going to be 4 to the 0 is 1, and then negative. So negative 1. 1, 4 to the first is 4, negative. So negative 4. All right. Notice it's going to be the same thing as this other one. It's just going to be negative values for y. If I did negative 1, that would be negative 1/4. If I did negative 2, it would be negative 1/16. All right, so let's plot these. 0, negative 1's right there. 1, negative 4, 1, 2, 3, 4, it's right there. 2 is not even on the screen. And then negative 1, negative 1/4. And then so you can see this one's going to look like this. All right, so it's kind of flipped across the x-axis. Again, it's going to approach the x-axis as your asymptote, but again, the curve is still the same. This one's just going to decrease very quickly from right to left. It's going to decrease instead of increase. So that's what that negative in front will do. All right, let's take a look at y equals 2 to the x minus 2. All right, we've already looked in this video earlier. Let's graph this one in blue of y equals 2 to the x. All right, and we said y equals 2 to the x was something like this. 2, 4, it was like something like this. Well, what we're going to see here is that this purple one that we're going to do, y equals 2 to the x minus 2, is going to be kind of a translation. How does that negative 2 focus in, or factor? So if we take a look at this, 0 minus 2 is negative 2, so it's 2 to the negative 2, which is 1 over 2 squared, which is 1/4. If we plugged in a 1, 1 minus 2 is negative 1, so 2 to the negative 1 is 1/2. If we plugged in 2, 2 minus 2 is 0, and 2 to the 0 is 1. If we tried 3, 3 minus 2 is 1, and 2 to the first is 2. Now, let's plot those points. When I plot those points, I'm getting something that looks like this. So, how did that negative 2 in the exponent affect it? Well, it looks like it just moved it to the right 2 units, right? And that's what it does. It just translate the y equals 2 to the x to the right 2 units. If I would have put a plus 2, it would translate it or move it to the left to 2. Now, if I'm asked to find the domain and range, domain then would be all real numbers, because domain asks how far left or right it can go. This purple goes left forever and right forever. The range is y equals greater than 0. How high or low does it go? It goes up forever, but it never crosses the x-axis because that's an asymptote. God bless.